Hello, this is now question 4 for Edexcel's M1 January 2003. Now, I wrote the key bits of information on here. So the position vector of Q at time 0, so the point to get to Q is 6i plus 12j. Now the position vector of P is at the origin, so that's why I've written 0i plus 0j, but obviously I could have just written the origin on that one. The velocity of Q is minus I, 8i plus 6j kilometers per hour, and the velocity vector of P is 10j kilometers per hour. Now you could put the 0i plus 10j, but either way, that's what it looks like. So what I'm going to draw is just a representation of this. Okay, so what we've got here is, we'll call this Q. So we'll call this Q's initial position of 6i plus 12j. Okay, and it's moving, so I is to the left, so it's moving to the left and up. So it's sort of going up there, really. So sort of going off the board with a velocity of that. And then, so I'm just drawing the relative positions, and this is the origin. And that is going sort of that way. It's going away from it to the right with a velocity of 10j. Sorry, no, it's going to the away, sorry, 10j, not I. So it's I on the x-axis, j on the y-axis, obviously, so you can pay attention. So it's going up by 10j. So where this is going up and away, this is just going directly up. Okay? That's minus 8i, by the way, 6i. Right, so what does the question actually ask us? So that's the key bits from the information. Find in terms of P and Q. Find P and Q in terms of T. Now that may sound completely scary if this position vector and velocity hasn't started to make some kind of sense. Now, the fact that it says position vector, that's the biggest thing that gives it away to me. Now, the only thing that we use position vectors for, in relevance to a topic, was vector equations of lines. And we said it was something like R0 equals R plus lambda. No, R0 equals A plus lambda B, sorry. Something like that, with A being the position vector, or to get to it from the origin, or a point on the line, and then B was his parallel vector, and lambda was the time. Right, okay, so this, if you can imagine, if we related to this exact idea, what we've got here is, sorry, one second. So that R0 on the board there, my computer's just frozen. Great, brilliant. Anyway, so this R0 business, that's saying, I know it's quite confusing, but try and put it nice away. So basically, this position vector, we can imagine that to be A, okay? And this velocity to be B, because the velocity doesn't change, it's parallel. We can imagine it's parallel, the parallel part of the vector. And this lambda, well, we're going to find out in a minute, in terms of t. Now, the only thing that we use t for is, well, velocity times is the extra distance. So that's the distance along. So therefore, this lambda bit must be t. Because this velocity is kilometres per hour. So we need to know how many hours to add on. So therefore, this lambda bit must be the t. Therefore, velocity must be a parallel vector. So therefore, that must be a. Okay, so you can just write it as R0 is equal to, so basically what you do is you put, for Q, you put the position vector as minus 6i, plus 12j, plus t, because that's the same as putting lambda, minus 8i plus 6j. And then for for P, you could put 0i plus 0j. Again, you could do this in column vector form, which I will do for you as well, plus t, and that's just 10j. Again, you could put 0i plus 0j, right? So you could put that as 6, 12, and then plus t, 6 minus 8. R is 0, 0 plus t, 0, 10. Okay, so that'd be the column vector. I'm not going to write it down, but hopefully you got it from that. As I said, it's probably on the mark scheme. If my computer could actually manage to start up without crashing, I got a bit on this computer as well, you know, 3 HP. I mean, I just avoid them at all cost. Right. works. Right, just have to go on the blinds on this one, I'm afraid, until my computer starts up. Right, now if you didn't get that, this next question is going to be a little bit more difficult. However, it actually might help you to realise this is something that we should have done. Calculate the distance of Q from P when t equals 3. Now, as these are two position things that we need to work out, obviously we need to sub t to be 3 to find out where O is and where Q is after 3 seconds. Now, you don't need to draw this, really, because you can just look at the two position vectors and decide the distance between them in terms of the i's and j's or whatever. Okay, so I'm going to put this as, so the first R0, that is Q, and the second R0 is P. So Q is 1 and P is 2. So what I'm going to do is, oh, it started up. You know, sometimes I just think, I should do the algorithms, not the computer. Right, okay, so we need to find out, first time we're going to find out where Q is. So Q. So we said R0 is equal to 6i plus 12j plus t. Now we know t is 3, so we just put 3 there. Minus 8i plus 6j. Okay, so we simplify it down, so that stays as 6i plus 12j. Take 24i plus 18j. Simplify that down, grab the i's together, so that's 30i plus 30j. Okay, so that's where Q is, so that's Q's position after 3 seconds. We need to work out where P is, so we'll do the same thing, put T as being 3, so, sorry, this 1 and 2, sorry, that was the part A, this is now part B. So we found out where Q is, and I think I said that anyway. So 0i plus 0j, don't need to write that in, but I just like doing it because it signifies that we're not missing anything out. Plus 3 times 10, which is j, which is 30. R0, therefore, is 30j. The position of P is 30j. Now we could put P as a position vector as 0i plus 30j, but that questions the belief that why don't you just put 0k? You could do if you wanted. Right, so essentially that is the position of Q and the position of P. Right, now this is quite a nice one, you don't really need to do anything. Because, remember, I is to the right. Is that going correct? Oh, I've done something wrong. Sorry, it's not minus 24, okay? So this is minus, so, sorry about that, I completely got that one. So it's minus 18i plus 30j, not plus 30i plus 30j. That's easy as stuff. Right, okay, so we've got Q is, it's got 18 to the left and 30 up. Now you could draw this as just a standard sketch if you wanted to, but really you just need to know the distance between them. Now they're both at the same height, it's just Q is 30 to the left, 18 to the left, if I can get this right at any point. So therefore it's got a distance of, so P to Q is minus 18i. That's just Q take P. Okay, to get from Q to P. Okay, hopefully that makes sense. Alright, so I'll just double check when the computer decides it's a good time to start working. Alright. Hello, welcome back. Sorry about that, just had to check this. Right, okay. So we know they're at the same point at this point here. However, because we're considering when this is right way around, effectively read the question first. When we're considering when Q is north of P, we're not considering if it's left of P or to the right. We're only considering about the J column. So we can assume I to be 0. Okay, so in this case, minus 18i would be just 0. So what we're going to do is, these are the position, yes, but this is the velocity. So we're going to make the i's equal to 0, so that, or I be 0. So therefore, this minus 8i is going to be irrelevant. We're looking at these two, the 6j and the 10j. Oh, sorry, no. a mess of that. But the principal stands, we're not considering the eyes. Sorry about this. Just a little bit. This question isn't very well explained, so I'm in a bit of trouble because I didn't get this one right when I did it. So I'm just making a bit of a mess of it now. Is there 6 take 8t equals 0? So. Alright, okay. So sorry, I'm looking up there. You're looking at right. I've got this. I'll get this correct now. So this is correct. You're looking at the vector equation of the line because we want the position. That's the position when t is 3, but relevant. That's the position vector. That's the velocity vector. So we combine them into this formula to say where q actually is. So that's what we're looking at here. So as I said, we're ignoring the i's. The i's equal 0. So if q north of p, if q is north of p, then I equals 0. So therefore, this 6 take 8t, so that is going to equal 0 because it's 6 plus 8 times t because right. So that equals 0. So 6 take 8t is 0. So you simplify that down to get t is 3/4 or 0.75. Right. So I do apologise about that. Made a bit of a hash of that. If you didn't get that last question, don't worry, because I made a complete hash of it myself. But as I said, hopefully the rest of the question wasn't too bad. I mean, it's only worth 2 marks out of the entire paper, so you know, it's nothing to. If I can't do it, then I would concern yourself too much. Although saying that, I'm not that good, so probably would still be quite worried. Anyway, so hopefully that kind of helped in some way. Sorry about that bit at the end, but kind of explained it towards the end of the video. Thanks for watching, and we'll see you in the next video. Hopefully you get it right this time.